To start off today's video, we'll address the elephant in the room. What is a flowchart? Well, let me tell you. It's like the thing we used in the first example. It describes how streams flow through a process, and as we move through the class, these processes will get pretty complex. It's up to us to be able to properly construct a coherent picture to fully describe what's happening in a process, so Eric from management doesn't mess everything up. To create a flowchart, we'll always need to follow these steps. 1. If a diagram is not already given, identify how many units there are along with the streams going into and out of them and draw accordingly. Next, we'll have to label everything. You want to start off by writing down all your givens, like if you have a 20 kilogram mix of 0.2 mass percent of sugar and 0.8 mass percent of flour entering a combustion chamber, the output being unknown because it's probably what you would call Eric for management. If there are a lot of different components, we may also want to consider creating a key so we can assign each component a letter to make labeling easier. Finally, we can assign algebraic symbols for the unknowns, aka in this case we would put M's for the output streams we don't know. We always want to use symbols to make solving much easier. And that is how we create a flowchart. And now we'll actually have to do some real engineering and solve the thing. Before we can actually go feet first into solving the process, we really need to start by doing a degree of freedom analysis. Basically, we use this to make sure we can solve for all of the unknowns before we waste all of our time and come to that conclusion 40 minutes later. What we really want is for there to be no degrees of freedom or more than none, because then we have some wiggle room. If there are less than 0, then we really have an issue. To calculate these, we'll use this equation. N for the number of degrees of freedom equals to n, the number of independent equations, minus the number of unknowns. So to do this, first, with a fully drawn and labeled flowchart in hand, we want to count up how many components we have. In this case, we would have sugar and water, so we have 2 components. Then we can count the unknowns, which again is 2. Then we can plug that into our handy dandy equation and find that we have 0 degrees of freedom, so this process is solvable. When considering unknowns for mass or mole fractions, always keep in mind that the sum of the fractions always has to add up to 1 or 100%, so that relationship can remove an unknown right off the bat. If, however, we added in a third unknown, we would then have a -1 degree of freedom. At this point, we should take a basic, or basically pulling a number out of thin air, to be able to solve the system. Now, after all that, we can actually balance the equation, and to do that, pretty simple. All we have to do is write out all the possible independent equations and then solve for the unknowns. Once you have some practice, you'll find ways to more efficiently solve for unknowns by writing down certain equations in a certain order, but to start off, we won't worry about efficiency, but more so doing it correctly. The last thing that I want to touch on was scaling a process. So going back to our flowchart, we have 20 kilograms entering the unit and 2 unknown product streams. But let's say we wanted to expand the process, so instead 200 kilograms were entering the unit. First, we have to find out the scaling factor. So take what we want the final amount to be, or 200 kilograms, and divide that by our original 20 kilograms. We get a scaling factor of 10. With this scaling factor, we then want to multiply the stream flow rates by the scaling factor, not the mass or mole fractions. We always have to keep in mind that the fractional amounts will always be the same, no matter the amount in the total stream. Now, here are a few example problems. Try to struggle through them before watching the solution video, but please don't cry.